Okay, so I think this might be our last graph. Anyway, I probably shouldn't make promises. This one does have a phase shift. So it also has a vertical shift. That's probably not as big a deal because hopefully you're seeing the patterns now. We've done quite a few graphs, and you know the vertical shift's just going to shift the whole thing up or down. But the phase shift, we're going to have to worry a little bit about that because it's going to change where our asymptotes go. Okay, so this is in the form y equals a cotangent bx minus c plus d. Okay, so we know we have a vertical shift down 2, and we're going to have a stretch of 4. And then what will the period be? Well, the period is going to be pi over the absolute value of pi over 8. And that's going to get you 8. So quite a large period here because it's going to go to 8. Now, the trick, though, on the phase shift. So the phase shift like we've done before, is c over b. And in this case, that's going to be pi over 2 over pi over 8. So think pi over 2 times 8 over pi. Pi's are canceling, and so you're going to get 4. So there's going to be a phase shift of 4. But what does that do to the asymptotes? So this is the part that I haven't written it on one of the previous screens. So the asymptotes, you're thinking, well, they're going to be at x equals pi over b, pi over b. Oop, forgot the absolute value. So pi over b, k, and that's what we had done before. So if you remember with cotangent, they're going to be, all the asymptotes on a normal one would be at an integer of pi. So 0, 1 pi, 2 pi, 3 pi, like that. Negative 1 pi, negative 2 pi. And k is an integer. But because there's a phase shift, we have to scoot it over. So we're going to add c over b. So in this case, you see that it's negative there. So it's, subtraction. So it's going to shift, in our example, this is going to shift to the right. Now, it's periodic, so if you want to think of it shifting to the left, but you have to be careful how that works. So this one's going to be okay, though. So I'm going to show it on the graph. All right, let's get some graph paper. And I'm just going to do one period. You could do more if you wanted to. So the thing is, you want to get your bearings. We know what the period is. Oh, the period is 8. And then we know the phase shift is 4. So if I mark off 8, let's say 8 is there, but I have a phase shift of 4. So 4 would be here. Now notice this is not pi, not 8 pi and 4 pi. It's just a plain, regular, real number 4 and 8. Okay, but the asymptote that used to be here at 0 is scooting all the way into 4. Okay, and then that means that my period is shifting over. So I'm going to go out here to 12. Hopefully that looks somewhat to scale. And then that would be my next asymptote. So my period here is 8. Okay, so that accounts for the phase shift and the period. Okay, now what we have to do is put in some more counting things and little marks on the grid, and then we can graph it. All right, so we are here at 8. That's going to be right there on the x-axis because that's what our cotangent curve does. And then we're going to cut that in half and cut that in half. But we're not going to go up to 1 because it's got a stretch factor of 4. So 1, 2, 3, 4. Oh, but it shifts down too, doesn't it? Okay. Well, that's okay. 1, 2, 3, 4, but it shifts down 2, so 5, 6. Okay, that will work for us. All right. So normally we would be at 1, but we would go up to 4 for the stretch factor, but then back down 2 because it's going to shift down 2. So shift down 2. Okay. And then there we are at 8, 0. And then down here, we're going to be, this would be what? 10 on the axis. So on the x-axis, it would be 10. We would go down to -4, but then we have to go down 2 more because it's really down there at -6 because it's shifting that way. Oh, you know what? I didn't shift my 8. That's why it looks all goofy. It would normally be there, but the vertical, see if I can squeeze that in. But the vertical shift down, I forgot to move it down 2, so let's move that down 2. And sometimes I like it when I make mistakes. I don't really like it, but I like to show you what you can do when you make a mistake. Like, you know, if you say, oh, this doesn't look right. Oh, well, go back and think about it a little bit and see what do you think went wrong, you know, kind of thing. So that's an important skill to learn because you're going to make mistakes. It's hard to be perfect on math. Okay, well, it doesn't look very curvy. You should have a little more curve in it, but anyway, that would be the graph then, and I just graphed one period. You could do more.